Hi there, this lesson is all about surface area. If you were to paint a box or cover some sort of three-dimensional object with some sort of material, you would need that object's surface area. So the definition comes straight from the terminology of surface and area. So here is the definition. The area contained in all sides of the solid, the outward portion of the solid. But what's a solid? Let's define that. A solid is a three-dimensional object. Here are some examples. Got a rectangular prism, cube, cylinder, cone, sphere, triangular pyramid, all sorts of three-dimensional shapes. Let's consider creating some formulas for the surface area of some of these shapes. A rectangular prism is essentially a box. So let's take apart the rectangular prism and figure out how we would find its surface area. There's a box. Say it has a length, a width, and a height. So if you were to take a box physically and cut it open, so that you would have these rectangles to add up the surface, you could do that. Let's start with the base here. So I'll start a different view on that. This is the length and the width, and that's my shaded base. So I'm going to flap open all the sides. So we've got that part and that part, and these parts flattened. And then we've also got this top here that we can tack on, and it's exactly the same as the shaded base. So that was length and width, and these parts were height. Okay, so we've got 6 sides, and you can notice that there's 2 of each type. You've got 2 of the length times width ones. You've got 2 of these width times height ones. And you've got 2 of these other sides, which are length by height. So you can see how easily you can create the formula. You don't need to memorize this formula. You basically need to understand that a prism, a rectangular prism, is made of 6 sides, 3 different types of sides, 2 of each component, where you multiply the different dimensions. Let's consider a cylinder. Cylinder's got 2 circles, like a can. So let's take apart a can. So let's say you had a can of beans and you're going to cut it open. The bottom part is a circle, the top part's a circle. If you took those circles off, you'd have 2 circles. And usually the radius is given. So you have the radius here, and you can find the area of those circles. They're always pi r squared for the area, which we determined in a previous lesson. So really that gives us 2 pi r squared covering both these circles. The rest of the can would then be a cylindrical shape, which you could slice open. So let's imagine slicing open a can of beans without the top or bottom and rolling it out. So if you roll it out, you can imagine you'd actually have a rectangle, which we know how to find the area of a rectangle. So the height here, this slice, is represented here. Now watch carefully what would happen if you sliced it open here. This part would actually go around, and this distance would be given by the length of this rectangle. And the distance around the circle is called the circumference, which we defined to be 2 pi r, or pi times the diameter. Same formula because diameter is twice the radius. Let's use the radius because we're using the radius here already. So to find the area of this rectangle, we just need length times width, which gives us 2 pi r, which is the base, times the height. I'll just write it like that. So let's put all those parts together, and that gives us our formula. So we've got 2 pi r squares, two circles, and the circumference, 2 pi r, times the height. And there's our surface area formula for a cylinder. So it is really important to actually understand how the formula is derived, not just memorize the formula. Because what if this part, you didn't want this part in your formula? Well, you just alter it and say, I don't have 2 pi r squares. If this part here was gone, this top circle was gone, you would just say you have 1 pi r square for the bottom circle. So it is interesting to see how it's developed, for sure. Let's check out a sphere. A sphere is a ball. So imagine a three-dimensional ball, and you have a radius. That basically, and that's the only measurement you can have, or the diameter, radius or diameter. Now the surface area formula has been derived using calculus to be 4 times the area of a circle with the same radius. So if you don't want to use calculus at this point, you could take, for example, an orange or some sort of circular object that you could peel it up into little bits and check. If you had 4 circles with that same radius, the orange, the surface of that circle, should fit into all four of these circles. So that is the formula for surface area of a sphere. That's probably one of the formulas you'll probably just need to commit to memory. Let's check out some surface area examples. This example here actually combines 2 of the formulas we've been using and alters them slightly. So let's check it out. If we take apart this shape here, we have a dome, so a semicircle on top with a radius of 2 meters. And we also have a cylinder, but the top of this cylinder is not actually included because it's not on the surface anymore. So you need to alter your formulas a little bit, and hence you need to understand how the formulas are created. So let's check out surface area of a sphere was 4 pi r squared. So 4 circles was the surface area of a full sphere, but this is only half a sphere. So we want to take half of 4 pi r squared to get this dome shape. Then we need surface area of a cylinder. Now the top circle has been removed, so it's no longer 2 pi r squared, but it's just 1 pi r squared to give us this part. And then we have the cylinder part, which we found to be the circumference, 2 pi r, times the height. Okay, let's fill in the blanks and see what this gives us. See how much paint we need for this. So the surface area is half of 4 pi r squared, so half of 4 gives us 2, because half of 4 is 2. So you got 2 times 3.14 for pi, times the radius, which was 2 squared, plus you've got 1 circle on the bottom, which is 3.14 times the radius, which is still 2 squared. And then you've also got 2 times 3.14 times the radius, still 2, times the height of the cylinder, which was 4. Let's compute that. I'm just going to type that in to my TA83. You could go piece by piece and calculate each of these components first and then add them. Depending on what calculator you have, you should get an answer of 87.92 meters squared.